So here it is told that let f be a function which maps from w to w, where w is the set of all whole numbers. It means that it includes 0 and all natural numbers. 1, 0, 1, 2, 3 till infinity. And it is defined as f of n equals to n minus 1 if n is odd. If n is odd. And it is equal to n minus 1 if n is even. N plus 1 if n is even. Show that f is invertible, hence find the inverse of f, where w is a set of all whole numbers. Okay, so now therefore we have to show that f is invertible. It means we have to show that the function f is bijective. It is 1, 1 and on 2. Then only it is invertible. Now suppose, for example, f of 3, that is equal, so 3 is odd, so this will be 3 minus 1, which is equal to 2. And f of 2, so 2 is even, so that's why it will be 2 plus 1, that is equal to 3. So f of 2 equal to 3 and f of 3 equal to 1. Similarly, f of 1, that will be equal to 1 minus 1, that is 0. And f of 0, so 0 is even, so that will be 0 plus 1, that is 1. So f of 0 is 1, f of 1 is 0. And then f of 3 is 2, f of 2 is 3. So therefore, f of 0 will be 1, f of 2 will be 3, and then f of 4, that will be 5, etc. And then f of 1, that will be 2, f of 3, that will be equal to, sorry, f of 1, that will be equal to 0, f of 3, that will be equal to 2, f of 5, that will be equal to 4, etc. So therefore here we can see that it is 1, 1. Therefore the function f is 1, 1. Since why? Since a since that if f of x1 equal to f of x2, then this also implies that x1 equal to x2. Since for different values of x, the value of the function f of, for different values of n, the value of the function f of n, that is also different. And also we can say that the range of the function f, that is also equal to the set of whole numbers, which is also equal to the codomain. It's also equal to the codomain of the function f. So codomain and range both are w. So therefore the function f is onto also. So the function f is 1, 1 and onto. So it is surjective. So I can say that the function f is both 1, 1 and onto. So it is a bijective function. Therefore f is a bijective function, and hence it is invertible. And the function f is invertible. Here w is a set of all whole numbers. Okay, so now f is invertible. So now we have to find the inverse of f. Now therefore, so from here you can say that if we take f of n, that is equal to m, suppose, so then m equal to n minus 1 for n is odd, when n is odd, and it is equal to n plus 1 if n is even. So therefore we can say that n, that will be equal to m minus 1 if m is even, that is equal to m plus 1 if m is odd. So n that I can write it is f inverse of m. Now here you can see that f inverse no m that will be equal to n plus 1. So here that there is something wrong. This we have to write this is odd, this is even. Okay. So m that is equal to n minus 1 if n is odd, and m is equal to n plus 1 if n is even. So therefore n will be equal to m minus 1 if m is even, and n is equal to m plus 1 if n is odd. N is odd. Therefore n is even, then this is 2 plus 1, that is 3, and if n is odd, this is n minus 1. So now f of 2, therefore f of 2 that is equal, so this will be plus, this will be minus actually. Since here if n is even, then n plus 1 is odd actually. If n is even, then n plus 1 will be odd. And then here if n is odd, then n minus 1 is even. So if m is even, then we should write m plus 1. And if m is odd, then we should write m minus 1. Since f of 2 that is equal to 3, so it means f inverse of 3 that is equal to 2. So now therefore the inverse function f inverse of n that will be equal to n minus 1 if n is odd, and that is equal to n plus 1 if n is even. So therefore we can say that the function f of n that is equal to f inverse of n. So therefore we can say that the given function is the inverse of itself. The given function is the given function f is the inverse of itself. So this is the required answer. And we have also shown that f is invertible since it is bijective, since it is 1 1 and 1 2. So hence proved here. Okay, so hope you have understood. Thank you.